amongst other, how to effectively manage, share, and utilize knowledge. This, of course, is not different in material manufacturing, where manufacturers or many manufacturers still rely on fragmented systems, siloed expertise, traditional databases, all of which hinder agility and innovation. And as you probably know, for SMEs in particular, this challenge is even greater with limited resources, skill gaps, and the complexity of integrating digital solutions that often slow down progress. So the question is, how can material manufacturers bridge the gap between traditional database systems and more modern, intelligent, data-driven solutions? And today's Data Bytes will tackle exactly that through the lens of the EU-funded DiMAT project. If you take a look at the agenda, today we'll talk about the common needs and obstacles for SMEs, what modern data management and manufacturing looks like, some semantic technologies for so-called fair management data, how to bridge a gap between classical database systems and modern data-driven solutions, how you can select the right digital tools for you, and finally, some practical examples from the DiMAT project. And I'm absolutely delighted to be joined by two experts who bring a wealth of knowledge to this topic. On the one hand, we have Ms. Marina Munar, who is an R&D project management manager at ITEX, a Spanish research center focusing on advanced technical services across sectors, including textiles, apparel, technical textiles, and cosmetics. Ms. Munar is leading innovative projects within international frameworks, such as Horizon Europe and Age 2020, driving advancements in the textile industry. On the other hand, we have Dr. Lukas Morand, who is a postdoctoral researcher at the Fraunhofer Institute for Mechanics of Materials, that's the IWM, which is a leading research center in the experimental and theoretical characterization of material properties. Dr. Morand specializes in modern data and workflow management techniques and the integration of numerical solutions, simulations, and machine learning solutions to enhance materials engineering. And by the end of today's session, you will gain actionable insights on how to leverage digital and semantic data solutions to make more informed, intelligent, and future-proof decisions. Do check the chat where you can post your questions to our speakers because there will be a Q&A session following their presentation. Marina, Lukas, we're all looking forward to today's webinar and your input. So without any further ado, the floor is yours.
All right, so I am Marina, and I will talk now about the common needs and obstacles that manufacturing SMEs face in digitalization. As Maxime said, I work at ITEX, which is a research and innovation center, which is specialized in the textile industry, but a little bit in cosmetics too. And just to give you a more clear view, we perform both characterization trials and textiles materials and articles for different sectors like healthcare and sport surfaces. But we also do have an R&D department also for the whole value chain of the textile industry, where we do research on technical fibers, new materials, finishes, dyes, and we have one group dedicated to the research of smart textiles and digitalization, which is the research group I'm part of. Lucas? Okay, so since we work SMEs on a daily basis to work on the R&D projects, I will not talk about what we have detected that are the needs that most SMEs find and the common obstacles that they face. So one of them is that they need skilled employees to ensure productivity and innovation, but at the same time, it's hard to find people with the right skills. For instance, the textile sector is very traditional and there are not many academic courses about it. So finding people that are interested in it, but that are also interested in digital technologies is hard. They, of course, also need affordable technology and processes that enable them to stay competitive but the integration of those can be very costly. We are working, for example, on AI-based solution to detect errors in the manufacturing processes on industrial weaving looms to find patterns to try and prevent the errors, which would also reduce waste. But these solutions are very expensive to implement. Say a company is spending 20,000 euros on a second-hand weaving loom because they are very expensive. They don't want to spend another 20,000 on a system to detect the errors. Also, this is very influenced by the fact that people in charge in these SMEs are usually from older generations, so they are a bit reticent to technology change. There are also many new regulations coming up, especially related to sustainability, that the SMEs need to comply with, but many times we find that they are not even aware of them. And most times, one of the bigger issues is that they don't have enough financial support to try and start the change towards digitalization. We find very big difference between SMEs depending on their location. The further away they are from the capital cities, the more behind they are from being digitalized and the less resources they have. So as I was saying, for example, if you took a look to the charts on the right by the OECD, on the top you will see a division by countries of the percentage of SMEs increasing their digitalization and the share of SMEs with broadband access, meaning that Swedish and Danish SMEs are the ones with more access to broadband, which is comparable to the level of digitalization. While, for example, Colombia and Ireland, which have more rural areas, are less digitalized but have a higher percentage of increase in digitalization. And on the bottom, you can see the same division, but this time is made by sectors instead of by countries. So that would mean, for instance, that the ICT sector, of course, is the most digitalized, which makes sense. And for example, real estate services are the ones with the highest increase in digitalization. And you can see that for the manufacturing sector, there's still a long way to go. So in order to bridge this gap, we are working with the SMEs, both doing tailored projects for and with them, and helping them with the access to calls for public funding. But we are also using the public funds that we receive as a research institute to work toward things that will be helpful in the near future. There are many initiatives right now organized by the European Union targeting this challenge. For instance, as Maxim also mentioned in the presentation, ITEX and Fraunhofer, we are both participating in a project called DiMAT, which is a holistic solution for the whole manufacturing process. And we're working on 4 different pilots, one about polymers, another one about composites, about glass, and about graphite. So as you know, the lessons we've learned is that the way to work with the SMEs on the textile sector is to start small and then scale up, hopefully with the help of some public funding. Also keeping in mind that it's very important to invest in training the people that work in the company and making small changes at a time to overcome the resistance. We've seen many cases where companies invest a lot of money on digitalizing manufacturing process, integrating sensors and ways of extracting the data. And then the operators find it very hard to use, and they stop using that and keep doing it the way that they've always done it, which is a shame because these companies can really benefit from the data management to help them reduce waste and improve their efficiency. So yeah, basically the key point is that the manufacturing SMEs do need access to digital solutions to keep up with the world today. And these solutions need to be easy to integrate and user-friendly from the employee's point of view, who are the ones that at the end will use them. But they also need to be cost effective and need to show a return on the investment that the company has made. Ideally, we will work with open source digital solutions that cover all the above mentioned needs, and that also consider the whole value chain from the data management to the production. But for all these digital challenges that the SMEs face, and to begin with the digital solutions, we need to first go back to the very, very basics and take a deep look at the importance of data management. And for that, I will now give the floor to Lukas.
Thanks, Marina. That's exactly my point where I will start. I will talk about cutting-edge semantic technologies to enable fair data management. I'm Lukas Morand. I'm working at Fraunhofer Institute for Mechanics of Materials, IWM. Before I start, I quickly say some words about Fraunhofer. So Fraunhofer is one of the biggest research organizations in Europe. We are focusing on applied research. That means that we try to bridge the gap between basic research and the industry. And Fraunhofer comprises more than 70 institutes, each having their different focus areas. And we at the Fraunhofer Institute for Mechanics of Materials, wait for the next slide. No. Yeah, at the Fraunhofer Institute for Mechanics of Materials, as the name says, our focus area is materials manufacturing, and the analysis of behavior of materials. And we focus on traditional research fields in material science, like materials modeling and characterization, or the assessment of components and manufacturing processes, for example, in terms of efficiency and lifetime. Nowadays, however, as you might all know, digitalization plays a key role in material science and manufacturing also. And therefore, we have a really big current focus currently on digitalization of materials and process data. And our aim is here actually to generate value from this data using data-driven tools. And data-driven tools, this is the start of my talk now. And we are all trying to apply data-driven tools, or we are all applying them, of course. I guess you're also applying them. I also do this. But there are certain obstacles. So when you apply, or you want to apply such tools, you typically don't have your data available such that you can use them directly. So there is an interoperability gap that hinders the effective communication of your tools or your solutions with your data sources. You can see this illustrated on the right. So you have typically different data sources in materials manufacturing, like databases or experimental data, test data, standards, and documents. And you want to have your tools actually access all of them, but for this you have to convert your data and write these cumbersome data conversion and pre-processing scripts. Also, this means if you don't do this and you can only access a certain amount of this data, you have a limited access to all of your data, and this restricts, of course, the potential of your solution. So at the end, you want to write these cumbersome data conversion scripts, and engineers typically lose a lot of valuable time when doing this. I will underlay this with a statement by a lead product manager at IBM, who said, most data scientists spend only 20% of their time on actual data analysis and 80% of their time on finding, cleaning, reorganizing huge amounts of data, which is an inefficient data strategy. And I'm pretty sure you would also agree that this fits to material scientists also. From my own experience, I can tell that I really need a lot of time to find, clean, and reorganize my data. The data I'm having for digital tools is not always a huge amount, that's true, but the data is typically heterogeneous. As said, experimental data, simulation data, and so on. And really doing all this limits my time that I can use or analyze the data, and this is really inefficient. And this is exactly where we want to help you, or we want to help the SMEs. And the key here is fair data management. And this is the core of my talk. And before I start, I would like to say a few words. What is fair data and why it is so important? So FAIR is an abbreviation for Findable, Accessible, Interoperable, and Reusable. I will give a quick example later about all of these words and what they mean, but basically this means that all of your data is available, and you can seamlessly get access to it and use it right away with your tools. However, often data is stored in file structures and relational databases and within an organization, and this is typically not fair. So what we want to do is actually to come from the left to the right, and this we do with semantic technologies. So we introduce a semantic level between the data sources and the usage, and this is typically a data space. And in this data space, every data is stored in a fair manner, and all your apps and your tools can connect to this data space seamlessly. The strengths are, of course, the interoperability. So each of the tool can communicate seamlessly to each other and to your data sources. The tools have full access to all the data, and this fosters deeper insights and better decisions. And you also don't need these data conversion scripts, and you are more efficient. Maybe one last word here also, fair data is typically seen as AI-ready data. So for future, your data will be stored here in a format that can be directly used by artificial intelligence tools. But now I talked a lot about semantic technologies. So what are semantic technologies? This might not everybody know. And here I will give an example at a very popular pyramid, the data information knowledge wisdom pyramid. And these are different levels of information, and the higher you get, the more you increase in semantics. And typical data-driven, the typical databases, they end up at the information level. So the bottom, you have the data level, and the data level is just like a number or fact. In that case, it would be 27. If you have 27, nobody knows what it means. So you have to be at least at the information level. So this number or this value should be connected to a quantity, and in material science, very important, also a unit, also in other fields of engineering. So in that case, could be elongation, 27%. But that is an information that a material scientist can work with. But it's also quite limited, because if you share this with somebody else, he says, okay, this is elongation as 27%, but he doesn't know anything else. So actually, for anybody else to understand all this information, you need to go to the knowledge level, and this you need to do with semantic technologies. So with semantic technologies, you can enrich your data with meaning and link it. That means you can store such statements like here on the right. A tensile test of a certain standard of a PET material in a full drawn yarn configuration showed an elongation of 27%. And if you share this with another material scientist, then he really knows where this value came from and what it really means. And the overall aim of semantic technology is of course to get some wisdom. So if you have a big database with a lot of such knowledge inside, and you might derive some other statements like PET material in a full drawn yarn configuration should have at least a certain tenacity to fulfill the product performance. But now this is like the idea of semantic technologies. How does it work? So when applying semantic technologies, every information is linked and stored in a knowledge graph. And this knowledge graph is here illustrated on the right. So this fits to the statements that we have seen before. So every node is a class, and every edge is a relation. And then you can see, for example, relation like the tensile test analysis generated an elongation. The elongation has a unit, which is percentage, and the elongation has a value, which is 27.11. So this in such a knowledge graph, you can quite flexibly store every information, and you can also add new information without having a really fixed file structure as you have it in typical databases. Also very important is that every term here is unique and defined. So If you share this knowledge graph with somebody else and it doesn't know what such a quantity means, then there is typically a URI, which is a link. Here, for example, you can see the link of the QUDT ontology for percentage. You can click on that and then you get a description what percentage means. So everything that is stored here is defined and it can be understood by everybody on the world, even if he is not a material scientist. So this is human readable, and very important, this is also machine readable. There is just one, I would say, rather big disadvantage, and this is that working with semantic technologies is typically very challenging. I can talk from my own experience here. I'm coming from the material science domain actually, and I'm working with semantic technologies since 1.5 years, and it was really hard to me to get in. So it's nothing that you do like besides work. So you need some support here, of course. To make this now a bit better, to illustrate this a bit better, I'll come with an example from textile manufacturing, and here you will see how this fair data management and storing everything in a knowledge graph makes actually perfectly sense. And this example is from textile manufacturing, so this is something that Marina works with. But I would say this also fits to many other companies in other manufacturing domains. So I will just start with it. So you have typically in your organization a production, in that case a textile production, but could be any other production. And your production has typically or often is a process chain. You don't have only one process, you have a process chain. In that case, in textile production, this is spinning, weaving, knitting, finishing, and dyeing. And what you have typically is that you have a material that goes into such a process, depending on the parameters of the process. The material gets changed, or the material state gets changed, and then the material is the input for the next process step. And so you have a really complex chain actually of information processing along your process chain. But that's not everything. You have also often an R&D department, or if you don't have any, then you might ask Fraunhofer or any other R&D organization to analyze, for example, your specimens. Then there will be directly after the textile has been produced, there will be a specimen preparation. You will have different specimens. There will be a testing machine, and from the testing machine, different data sets will be derived. So you have many other data sources directly connected to your process chain with a lot of many other data sets of different formats. And that's not everything. You have often also numerical simulations. You might simulate the materials or the process, and then you have other data sets that are stored. And additionally, you also often have external databases from partners or literature data or standards, or other sources. You see that here you have actually a lot of different data of different sources that are somehow connected to each other. And to represent this in a classical database manner, this is really, really cumbersome. So at this example, we can really see the challenges of data management if you want to have all the data available that you can see here. These are heterogeneous data sources, so all of the data that you will store here are from different sources, may it be a process or a testing machine or a simulation, external database. There are also a lot of heterogeneous data formats. So simulation files are different than files from a testing machine, which are different than sensor data or process parameters. So you have to work with all of these. Then you have also very complex workflows that you have to represent. That means like information processing workflow, which is, for example, your process chain. There is material states who will be changed along the process with different process parameters. So this is a really complex workflow that you have to represent, or also the specimen preparation, testing, and evaluation is a complex workflow. And this is also not easy to represent. This comes also along with data provenance. So data provenance means actually exactly the other idea of a workflow. So if you're at the end of a workflow and I ask you, where this information comes from, that you should be able to trace back every source of information, and this is also very hard if you have these long workflows. And then, as introduced at the beginning, you have your FAIR principles of data: findability, accessibility, interoperability, and reusability. And this is now the perfect example to show you how hard this is actually to get FAIR data. So findability means that you should be able to find all your data that you have stored. So imagine now you store everything here in different file structures, then it's really hard to find a data set. And it will be even harder to find it if I ask you 5 years later about this. Then accessibility is another difficulty. For example, simulation files often need to be opened with a simulation software. Then you need to know the version. So storing all this is also important. If you don't know it, you can even not open your data file. Interoperability, this is what we have been talking a lot since I started talking. This is that you can plug and play, that you can plug AI tools or other digital tools to your database and just execute them. You don't need to convert your data. And reusability means that everything is documented. This comes with semantic technologies that you, as said before, you store like a percentage, and then the percentage meaning is documented, and you can share this with everybody on the world also in 5 years later, and everything is really defined and you know what it means. So when you use semantic technologies, you have all these opportunities that you can integrate all your data in one data space in a fair manner. You can enrich the data with a meaning and link data, and then you can represent these complex workflows. You can make information from external data silos available, so you can connect them to your data space. Information tracking is possible via this linkage of data. And of course, you can seamlessly connect the digital solutions to your data. And now I want to introduce the DiMAT Cloud Materials Database, which is a tool for fair data management that we developed in DiMAT. It is a user-friendly, semantics-driven platform for materials and process data management. And our mission is to empower technicians and engineers to use semantic technologies. As I said, it's really hard to use semantic technologies, but with this tool, we want to make it easy. So you get all the advantages of semantic technologies and fair data without really having a deep understanding of semantic technologies. What you can see here is the front end of the CMDB, but I don't want to go into detail here. I want to rather show you that we, for example, this process chain that I've showed in the example before, this we have digitalized with the CMDB, and then it looks like this is a visualization that we get of the graph in the CMDB, the Cloud Materials Database. You can see the engineered materials, so items for the engineered materials, for the manufacturing process, for the specimens, for the testing machine, and the data set. So all these different data sources and data sets are connected and linked to each other. And if you click on them, then you will get information like metadata, process parameters, for example. Or if you want to have a look at the outcome of the testing machine, this is like here stored in a time series format. And you can see here then easily all the elongation measurement that have been conducted at iText within the DiMAT project. So a quick summary of our functionalities of the Cloud Materials Database to tackle these challenges. So we have a functionality of data integration. So we want to make data integration easy. This means that you can easily harmonize and integrate the data of heterogeneous sources and link it, and that you get then this knowledge graph as I have showed. Discovery of this knowledge graph is also not easy, but we have functionalities for you to explore the knowledge graph and find your information. And also, you have the possibility to derive new knowledge. That means you have your knowledge graph and every data is stored, and you can take a certain part of it. You can derive new knowledge from that. That means like you do a numeric simulation, and then you can store back your information in a fair manner in the database and link it. And where we want to get with this all is that we get to the recommendation part, that we really have knowledge-based decisions. So we want to improve decision support with this, with the full access to all the data. And this in future, we will want to enable automatically with AI tools. So some advantages of using CMDB, it's a robust tool for handling heterogeneous materials and process data in a fair manner. The user, the web front end, as I have showed quickly, is very user-friendly. I can tell this from my own experience. And we also have a very powerful Python interface for automation, so you can automate everything that you do within the CMDB. And you also don't need to replace your system, so the CMDB works on top of existing database system and can have access to all of this data. And of course, digital tools can seamlessly access all the integrated data. And here I will give a quick introduction on the DiMAT digital solution. So in DiMAT, we also do exactly this, that we develop digital tools that serve SME needs along the value chains in terms of digitalization. So the DiMAT toolkits that we develop are like tools for data and assessment, so for data storage, like the cloud CMDB, but also for knowledge representation and lifecycle assessment, but also we develop tools for modeling and materials design, and also for simulation, process and material simulation and optimization. And one of the advantages also of this is when you use it with the DiMAT Cloud Materials database, all of these tools can access your data in a fair manner. And if you ask yourself how you get access to the DiMAT toolkits, there will be a DiMAT digital solutions platform that you can access from everywhere in the world via the web. There will be a centralized access point, and you can just explore and select your preferred toolkits with just a few clicks. And our aim is here really to make the solutions available to SMEs to support their digital needs. And here I want to hand back to Marina.
All right. So when choosing the tools for the SMEs, whether it's for the textile sector or any other sector, it's essential to follow a structured approach to ensure that they meet the business needs effectively. So for that, the first step we do when we do our R&D project is to start by identifying the weak points and prioritizing the goals of the company, which most times are related to improving the efficiency. But right now, there's also a lot of importance on sustainability. It's also important to involve, as I said before, both the stakeholders and the operators in the decision-making process, because many times they have very different points of view. And then we will choose which tools will integrate smoothly with the systems that the company already has to make it more easy for everyone. And also taking into account that they need to have potential to scale up as the SME grows. Of course, the more intuitive the tools are, the easier they will be adopted by everyone. And of course, again, as I mentioned, it's very important to offer training services to the employees so that they get on board with everything. It's also better to begin with small essential tools and then explore the funding opportunities to maximize that investment. And it's also very important to look for solutions that address their particular needs and not just use general solutions. For example, in the textile industry, tools for yarns production, monitoring, or dye optimization can be highly beneficial in terms of maybe reusing water and being more sustainable, as I mentioned. And always opt for the most eco-friendly practices, not only to help the planet, but to also ensure our regulatory compliance. And finally, it's very important to test the tools on a small scale first, as it allows the business to gather some feedback and make better informed decisions before the full implementation. And in terms of that, as I mentioned, and Lucas also talked already about DiMAT, these types of projects allow companies to test the integration of open-end solutions even before they are released into the market. And these solutions that are solutions that are designed to be adopted by companies of all sizes without cutting on quality. So it's a really great way of trying things out and figuring if that works for you, or maybe get some ideas on how to improve the solutions. So, for example, the way textile companies can benefit from using the DiMAT toolkits, particularly in the melt spinning process, which, if you don't know, is the process by which most synthetic yarns are made. Right now, many businesses still rely on very traditional practices, which can be inefficient and inconsistent. So, these kinds of toolkits provide a smarter, more sustainable alternative. For example, traditional methods often require multiple trials, leading to excessive material waste and a lot of energy consumption from the number of trials. Whereas when using DiMAT toolkits, as it gives results based on precise formulations, it helps to reduce the number of trials and therefore energy and material usage. Production time, it's also a key factor, as the trial and error cycles can be slow and unpredictable. So DiMAT, with the predictive tools, can shorten these production times. When it comes to sustainability, also traditional practices often have a limited focus, and DiMAT also incorporates a life cycle assessment analysis, which ensures that eco-friendly practices are embedded into the process and taken into account from the very beginning. And another major advantage is consistency. Conventional methods often result in variability because they depend on subjective decisions, right, that the operator takes. But each operator can have a point of view and take different decisions. So with DiMAT, toolkits give you data-driven approaches, so it enhances accuracy and more specifically also repeatability, so that everyone takes the same decisions. And so if any of that sounded any interesting to you and you would like to try out these solutions, just know that right now there is an open call for early adopters up until the end of February. And you can go to the project's webpage either by typing the link up or by scanning the QR code that you're seeing, and you can sign up to try these solutions and see how they work. Give us your feedback to improve them. And yeah, that would be all. Thank you all very much for listening.
Thank you, Marina. Thank you, Lucas. Thank you so much. Very exciting stuff that you're doing in the DiMAT project. And we already have some questions in the chat, so let's jump right into those. We have one question regarding digital solutions as a service. So what do you think about digital solutions as a service, which could permit SMEs to use the services when or if they need it? There was a quick analogy here, similar to libraries used for knowledge gathering, where nobody ever bought all of the available books, but a library card instead, so they could access these books. So what is your opinion here on these digital solutions as a service?
Maybe I can take this one. Honestly, we had in Fraunhofer IWM, we had already the idea of this, and there was, I think, even a big EU project for that called Marketplace. And the idea was that you have a marketplace like like you can imagine Amazon or yeah, like Amazon, that you can go there, you can find your solution that you need, and then you can try it out, and then you can just purchase it and use it when you need it. There is, I think, also there is really how to say, there is a need from the market side, I would say, that because it's really hard, also for me, it's really hard to find a solution, like a simulation solution. I mean, if you have a process or material that you want to simulate, there are several frameworks to use, but you don't know which is the right, and there are several models, so this is really hard. So that would of course help. A difficulty here is also, the difficulty that we found is that you need somehow a translation, because you're typically at the industry, you have a problem and you need to find a solution, and to get this match, this is also quite hard. So, and this is also unsolved, I think, right now. DiMAT, I would say, so to bridge the gap to DiMAT, I would say it's somehow simulation as a service, software as a service. You have this platform, you have the tools. These are the nine tools. I did not show them in detail, but as said, it was for data management, assessment, modeling, design, simulation, and optimization. And you can use them. And yeah, I would say this is somehow simulation as a software as a service, because then you will get support from the DiMAT developers to use that simulation. This is also the aim of DiMAT, and we can provide this solution to you. Don't know if that answered the question.
I think it should be all right, and if not, I'm sure that a follow-up question
Okay.
will be
Let me
posted.
just grab a cup of water before the next question. Or if there is if there's a question to Marina, then maybe this is a good opportunity.
Well, let's see. We do have one follow-up question on the ontology. I'm not sure, Marina, if you feel comfortable answering that.
I think we will wait for Lukas.
That's okay. No, it's quite interesting, and I think that the immediate follow-up question here, building on the digital solutions, there's also a question that we have in chat here, is whether you are considering, so I will add to the question. The first part would here be, are you considering commercializing the CMDB? And then the actual question in the chat, what would your business model be like?
So that's a very good question. Of course, we are thinking of commercializing it. I mean, we are at Fraunhofer. We always aim to transfer this our developments to the industry, and make it accessible for the industry. How we going to achieve this is not decided at the moment. There are also some limitations. The CMDB, or the technology behind the CMDB, is also still under development, so we are still develop it further. And as we did not decide how we commercialize it, there is also no business model right now. At the moment, we are rather at a step that we are trying, as said, further develop the technology and find industry partners to collaborate with, and so that they can try it out as we do it in DiMAT and give feedback to us, so that we can really improve the CMDB to get it useful for industry partners.
Mm-hmm.
So if I don't know where the question came from, so if you're interested in testing it out or collaborating, then you might just use the chance with the call for early adopters, or you can also directly contact me. I guess you will find me on LinkedIn, and then we can have a chat.
Very good. We have one question on the application ontology. So did you develop a textile manufacturing application ontology? And if you did, what is the mid and top level ontology?
Also a good question. we have really a bunch of good questions. So in CMDB, let's say we had bad experience in developing the ontology from top to down. So when we started, this was not in DiMAT, this was even before, or this was in parallel to DiMAT, I think. There was always a big effort when people or engineers try to get data into CMDB, because then they need their ontological concept. And for having the ontological concept, this was also always really hard how to get it. So we started to follow a bottom-up approach. So the CMDB comes with a vocabulary service management, and then the engineer can he can define the vocabulary terms that he needs, so the ontological concepts. And we did this in DiMAT. So there is no textile manufacturing ontology, but a DiMAT ontology. It's not public at the moment. Yeah, we gathered the vocabulary from the partners that a vocabulary that they need to integrate the data and store this in CMDB. The next step would, of course, be to connect this with a mid and top level ontology, but this step has not been done so far.
Great, thank you. In the meantime, we will, because you mentioned the call for early adopters, we'll post this in the chat in a few moments. Someone will post it in the chat in a few moments. But let me ask a follow-up question as well, because I'm interested. So away from the technical part a little bit, but in the project, you're collaborating with a lot of leading material production companies. What is the kind of feedback that you've received up until now in terms of their digitalization needs? What are the priorities here, and what are the main challenges in terms of digitalization?
For the textiles, I mean? Oh, sorry.
Yeah.
So right now, as I said before, for instance, we are a research center, but most of our data was written down on a notebook that is passed from one tech to the other. So it's really hard to keep track and get good conclusions, because it's really hard to go through all the pages. So data management, I think it's a really big thing here, because as I said, it's a very traditional sector, so many things are still not digitalized. And right now there's also a lot of new regulations regarding sustainability coming up, especially for the textile industry, because it's a very it's an industry that produces a lot of waste and uses a lot of water. So I think it's really good that there are now some digital tools that are putting focus on sustainability and helping them redesign the process from the very beginning to focus on that and reduce both waste, energy consumption, and make smarter decisions regarding that.
Okay. Yeah, we see, especially also in terms of regulations, that there's a lot of regulation coming and already implemented in the last couple of years, and especially for SMEs, that seems to be a big burden because it's quite resource intensive in terms of time and in manpower.
Yes.
It's a big one, yeah. Let's us have a look in the chat if there are any other questions. Also to our participants here, you can still add questions, of course, if you have any. If not, then I would like to ask one extra follow-up question here. So we focus a bit back to the cloud material database. Are there any existing solutions, similar solutions on the markets already? And if so, how does the CMDB differ from those?
I would say there are certainly a lot of solutions also, or mostly the traditional database solutions. I think what that differs from is more or less clear. Database solutions with semantic technologies are under development, so there are also other solutions existing. I would say what makes the CMDB really unique are, I would say, 2 points. So one is these complex workflows. So you can, as you have seen with the process chain, so to model such a process chain and handle information from one step to the other, this is really easy to handle with the CMDB. This is, I would say, one thing that really makes it unique. And the other thing is also, as I said, semantic technologies is really hard, and the CMDB is actually really user friendly, I would say. So I am, as said, I'm working with semantic technology since a while, but I'm not an expert. But I can really easily use the CMDB and use these technologies. So we already boiled it down to a really low, so that there is a really low barrier to use this and to get into it. I would not say it's perfect at the moment, but we are always working to get it more user friendly and more user friendly. So really our aim is that everybody can use this. And I think this is also a big advantage of the CMDB.
Yeah. Super. Let me direct one last question to the audience. Is there any open question there? Please write in the chats or forever hold your silence. Or maybe not, you can still, of course, contact us or speakers directly, I think. Lukas, Marina, is there any last points that you would like to give as a closing remark to our audience today?
From my part, I think we are good. We already said everything we had to say.
Perfect.
I don't know, Lucas, but I think he'll agree with me.
Yeah. Of course, I will agree with you. No, I mean, the only thing that we can say, maybe one more time, but it has also been said, is the call for early adopters. If you want to try out the solution, the CMDB, or the other solutions, which are also quite interesting and may help you as SME, then just contact us.
Yes, the link for the call for early adopters is now in the chats for anyone who's interested. It's on the F6S website. Super. If the audience has no more questions, I also don't have any more questions. Then all we can say is thank you so much, Marina and Lukas, for your willingness to share your expertise here and to share a bit about what DiMAT is doing. I'm sure that if the audience has any further questions, they can reach out to you directly.
Yeah, of course.
Yeah.
Fantastic. For our audience, please know that we will send everyone the full presentation and the video recording as well, so you can have a nice reference point to look back to in case anything would be still unclear. That being said, thank you again to Lukas and Marina for this interesting webinar and for this introduction to DiMAT and the CMDB. Thank you to everyone else for joining us today. Have a fantastic afternoon, everyone, and we will talk soon. Goodbye.
Bye-bye.
Bye-bye.